What if the warmest homes ever built for Arctic winters were never designed to create heat at all? What if they survived because they learned how to stop heat from escaping? For generations, Viking villages have been imagined as places of endless hardship. Dark shelters buried in snow, smoke-filled rooms, people shivering beside fires that never seemed strong enough. That image feels logical. It feels inevitable. And yet archaeology keeps revealing something deeply unsettling. These homes did not barely survive winter. They were shaped for it. Not through technology, not through excess fuel, not through constant struggle against nature, but through restraint, through patience, through an understanding of cold that most modern buildings no longer possess. The Vikings did not ask how to make more heat. They asked how to lose less of it. That single shift transformed earth, air, smoke, animals, and human bodies into a unified system of survival. The real mystery is not how the Vikings endured winter. The mystery is why knowledge this precise was ever forgotten. The Viking longhouse was never meant to be understood as a building standing alone. It was not an object placed onto the land, but a system woven directly into it. Across Scandinavia, Iceland, and Greenland, archaeology reveals longhouses stretching dozens of meters, sometimes sheltering entire extended families beneath a single continuous roof. This was not crowding born of desperation. It was deliberate thermal design. Human bodies were never treated as passive occupants. They were recognized as constant sources of warmth. By concentrating many people into one enclosed volume, the Vikings transformed ordinary life into a renewable source of heat that never shut off. Warmth was not owned by individuals. It belonged to the group. Sleeping, working, eating, and speaking all fed into one shared thermal environment where every presence mattered. No one endured winter alone, because no one was meant to. Cold was not something to be fought person by person. It was managed collectively, through proximity, shared space, and a deep understanding that survival in winter was never an individual act, but a communal one. The shape of the Viking longhouse tells a story that is easy to overlook. Its gently curved walls echo the form of a ship's hull for a reason rooted in experience rather than style. Viking builders were sailors long before they ever became architects. They spent their lives reading wind, waves, and shifting forces in hostile environments, learning that survival rarely comes from resistance alone. At sea, a vessel does not defeat the storm, it rides it. That same logic was carried ashore. Flat walls invite impact. They absorb force directly. Curved surfaces guide that force away, allowing wind to pass instead of strike. Winter storms did not crash into Viking homes head-on. They slid along their sides, losing energy as they moved. The longhouse behaved like a grounded vessel enduring a permanent storm. Inside, air was slowed, movement was controlled, nothing rushed. Survival did not come from strength or defiance. It came from balance, from shaping space so that the environment could move without tearing life apart. Contrary to popular imagination, Viking homes were rarely built as towering log structures carved from endless forests. In places like Iceland and Greenland, timber was scarce, fragile, and slow to replace. Trees required decades to grow, while winter arrived every year without fail. Faced with that imbalance, the Vikings turned away from wood and looked down instead. Beneath their feet lay a material far better suited to the world they were entering. They cut turf directly from the land, thick slabs of soil bound tightly together by dense networks of grass roots. Stacked with care and precision, these blocks formed walls that could reach 2 meters thick at the base, narrowing as they rose. This was not crude construction born of desperation. It was applied physics shaped by experience. Soil contains countless pockets of trapped air, and still air is among the most effective insulators known. Long before insulation values or thermal science existed, the Vikings learned this truth through survival. Their walls did not fight the cold. They slowed it, held it, and refused to let warmth escape. Turf walls did far more than shield Viking homes from the wind. They functioned as reservoirs of warmth, quietly absorbing heat and releasing it back into the living space over time. As fires burned along the central hearth and people moved, slept, and worked inside the longhouse, heat did not vanish into the winter air. It migrated slowly into the earth-packed walls, sinking into layers of soil, roots, and trapped air. Once absorbed, that warmth returned gradually, radiating back into the interior long after flames had faded. The house did not cool suddenly. Temperature shifted at a measured pace, softening the extremes of winter nights and conserving precious energy. Over time, grass regrew across the exterior walls, tightening the structure even further. Roots bound the turf together, sealing gaps and locking the mass firmly in place. The house no longer rested on the land, it merged with it. Nature was not kept outside at bay. It became part of the architecture itself, an active participant in the system that kept people alive through the cold. During the coldest months of the year, Viking families did not isolate themselves from their animals. They brought them inside. Cows, sheep, goats, and horses were housed within the same long structure where people slept and worked. To modern sensibilities, this feels unhygienic and primitive. To the Vikings, it was precise energy management. A living animal is a continuous source of heat. A single cow produces as much body warmth as several modern space heaters operating without pause. Multiply that by an entire herd, and the result is a steady thermal output that never shuts down, never requires fuel, and never needs to be restarted. The longhouse was shaped to take advantage of this reality. Livestock areas were positioned slightly lower than human living spaces. As animals breathed and moved, warm air rose naturally, drifting upward into the areas where people gathered and slept. Heat moved where it was needed, without pipes, without machinery, without burning additional fuel. It was biology directed by architecture, a living system in which warmth walked, breathed, and endured alongside the people it protected. Cold by itself was rarely the greatest danger. The Vikings understood that wind was the true killer because moving airstrips heat away faster than fire can ever replace it. For that reason, Viking homes were designed to control air rather than temperature. Windows were nearly absent, not because glass was unknown, but because every opening was a weakness. Darkness was safer than drafts. Entrances were kept low and narrow, forcing anyone who entered to bend their body. This was not ritual or symbolism, it was physics. A smaller opening meant less cold air rushing inside, and less warmth escaping with it. Many longhouses included short entry passages that acted as buffer zones, unheated spaces that absorbed the shock of outside air before it reached the living interior. In effect, these were early airlocks, built centuries before the concept had a name. Inside, air was allowed to move slowly and deliberately. The house did not breathe freely. It breathed with restraint. Warmth was guarded, drafts were treated as threats, and survival depended not on how much heat could be made, but on how carefully it was protected. At the heart of the Viking longhouse burned a fire unlike anything found in modern homes. It was not pushed against a wall or hidden behind stone. It stretched through the center of the structure, a long open hearth that served as the thermal spine of the entire building. Beneath the flames, stone absorbed heat while the fire burned and released it slowly long after the embers dimmed. In regions where timber was scarce, peat replaced wood, burning evenly and steadily, providing reliable warmth without constant attention. There was no chimney. Smoke rose and gathered beneath the roof, by design, not by accident. As hot smoke pooled near the ceiling, it formed an invisible thermal layer that trapped warmth below where people lived and slept. At the same time, soot settled onto wooden beams, coating them in a protective layer that repelled insects, slowed rot, and preserved the structure from within. Air quality was never ignored, but it was managed with intention. Comfort was secondary, survival came first. The Viking roof was never intended to be a thin barrier separating people from the weather. It was built as mass, deliberate, and heavy, designed to slow the movement of heat rather than stop it outright. Builders began with layers of birch bark, carefully laid to form a waterproof skin. Above that, thick slabs of turf were stacked and compressed under their own weight, creating a roof that could weigh several tons. This mass stabilized interior temperatures and pressed the structure firmly into the ground, anchoring it against relentless winter winds. Over time, the roof changed. Grass took root across its surface. Moss spread slowly. Roots pushed downward, sealing gaps and binding the layers together. The structure repaired itself simply by being left alone. Snow was never removed. It was welcomed. Snow trapped still air, sealed cracks, and wrapped the house in an additional layer of insulation. What appeared buried was not abandoned. It was protected, held in place by earth, grass, and winter itself. Viking homes did not endure because they generated limitless heat. They endured because they learned how to preserve what little heat they had. Every element worked together as part of a single system. Earth slowed loss. Fire provided a steady core. Animals added living warmth. Smoke trapped heat. Snow sealed the structure. Human behavior adapted to the limits of winter. Nothing existed in isolation. Each part depended on the others. The house did not stand in opposition to nature. It aligned itself with it, borrowing stability from the land rather than fighting the climate above it. This was not legend. It was not myth. It was inherited knowledge passed quietly through generations, shaped by necessity rather than theory. As we live in a world increasingly dependent on energy, buffered from loss by machines and excess, one question remains unresolved. What other wisdom did we abandon when comfort replaced understanding? To remember these systems is not nostalgia, it is an act of preservation. History survives only when someone chooses to carry it forward and to treat memory itself as something worth protecting.